everyone. Thank you, Rated Power, for this wonderful event. Well, first of all, I would like to have some words on HCLTech. We are a very large IT engineering services company. We are present, we have offices around the world, we have more than 200 delivery centers and more than 100 innovation labs. We are more than 220,000 employees. And well, last fiscal year we have over $13 billion revenue. Okay, so we are present in almost all verticals, but of course in energy utilities and oil and gas, dealing with the leaders in this industry. So let's talk a little bit about intelligent asset management. First of all, some flavor on context. Okay, most important, I would like to remark these figures because we are expecting to reach almost 2,000 billion US dollars by 2030 in the renewable energy market. Okay, this means that finally the renewable energy arena is booming. But of course, this means nothing if we don't build the grid to integrate all these renewables. Besides, we can see also that there's a pretty nice growth rate for this decade. And other interesting trends that are present in the industry. Okay, we are seeing more and more flexible resources because they are more and more needed. Okay, these come, for instance, from electric vehicles and charging infrastructure, also other storage solutions, and this is also coming along with technology, let's say, deployment, such as Internet of Things, cloud and edge solutions, okay, that are fostering or triggering, let's say, better real-time monitoring and control, okay, which is allowing us to provide new business models, mainly in the regulated markets, which are generation and retail. And of course, we have to keep an eye on decarbonization targets and regulatory and compliance, as in every industry nowadays. Okay, these trends are wonderful, but they imply some challenges, as you can see here. First of all, now we have to deal with monitoring and control of large fleets of assets that are distributed geographically. Okay, this is of course a big challenge for us, and also the dynamic tracking of these assets. On the side of the operation, okay, we can see these examples of a frozen and burning wind turbine, but we also have to deal with cybersecurity risks that regrettably are getting more and more usual. Okay, we can also have other operational challenges such as curtailment, congestion, voltage control, etc., etc. On the side of the maintenance, okay, what challenges come from the predictive maintenance, because we want to limit the downtime, and we want to identify anomalies beforehand, before they happen. And of course, we want to extend the life of the assets, because this is very, very important for the financials of the renewable projects. And on the side of the power optimization, okay, we have to be very careful, and we have to push to reduce capex and opex in these projects. Okay, this is related to what I have mentioned before in operation and maintenance. Okay, because the more that we have the assets up and running, okay, and the longer they are operating, the more revenue they will give us. Okay, and finally, some other challenges that come from the regulator, because we have to comply with everything related to safety, security, and environmental standards. But also we are observing some challenges in system scalability and digitalization. Okay, so let's get in depth to the digital world. Okay, here we have the 4 stages, okay, of the life cycle of an asset, of a renewable asset. I'm just putting here the wind turbine as an example, but it can be a solar panel or whatever. So we have the R&D and engineering, then we have the manufacturing, the commissioning, and the operation, okay? So in the first one, we deal with product twins as designed. In the manufacturing, we deal with product twins as built, also asset twins and process twins. In the commissioning phase, we deal with product twins. And in the operation and maintenance, we deal with asset twins as maintained. Okay. In each phase, we can have different advantages. For instance, in the engineering, we have supplier visibility and quality. In manufacturing, we have the predictive maintenance and supply chain optimization. In the installation phase, we can leverage digital twins to ensure cost, quality, and schedule. Also very important, warranty optimization that is also very important for bankability of projects. And in the performance phase, okay, we have we can leverage these digital twins for performance monitoring, among others. But the point here is that we can build a digital thread, okay, that will allow us to manage the entire life cycle of an asset seamlessly and smoothly, okay, throughout the 4 phases. But what's a digital twin? Because this is becoming more and more popular, but I think it's relevant to explain. Digital twin is a connected virtual replica of the physical product, person, asset, whatever. And it's very important, this word connected, because it's usually not being considered, okay? But what makes this makes that the physical asset leverages the digital twin. For instance, beginning from the operation of the physical asset, we can gather and analyze that data and then provide feedback to the digital model to refine this model. Then we have some outputs from this model, we validate them, and then we introduce them into the physical asset for improved operation of itself. We can have different types of twins, as you can see here: product, asset, process, or infrastructure twin, okay, depending on the complexity of the challenge you have ahead. And how we approach this digitalization, how we approach a digital twin. Very simple, three phases: definition, building, and operation. The first phase is more based on consulting services. Here we have to identify, select which products, assets, or processes we want to digitize. We have to build a roadmap, we have to define the architecture, and we have to assess which sensors and IoT devices that will be needed. When building the digital twin, we talk about developing it, okay? Developing the solution. We have to deal with the content creation, we have to create the AI and machine learning models. We have also to build the dashboards, templates, alerts, and very, very important, the data integration between IT, OT, and ET. Finally, for the operation, we have to run and support these digital twins. So we have to update the business rules, the alerts, the notifications. Maybe we have to retrain also the artificial intelligence and machine learning models. And also we have to manage the applications and the IoT devices that we have in the field. This is our solution. I mean, I have shown here previously, we are product agnostic, but there are several vendors, but we are vendor agnostic, okay? We can work with all of them. And we can, let's say, optimize them with our own platform that runs on top of it. The challenges, I have talked about them earlier, so I will focus now on the benefits. With this platform, what we can do is to improve the asset performance, reduce downtimes, increase revenues, optimize configurations, increase energy operations, and reduce times and costs of commissioning. So one of the key functionalities we have here is to monitor the health of the assets and the farms, okay, with several metrics that can be customized, of course. We can also plot them according to the client requirements. And we also have, we can integrate it geospatially to, let's say, play with different weather and geographic conditions, okay, so that we can see how our asset or our fleet of assets is going to behave depending on different conditions. We have also a huge set of alerts that can be customized for each client. For instance, here we are focusing on wind turbines, but as mentioned before, we can focus on any other renewable source. For instance, we have here the nacelle temperature and the turbine vibration. And also, of course, all this is based on AI and machine learning models that allow us to predict the efficiency of our assets, but also the energy generation, among others. Okay, for instance, you can see here the performance of the different wind turbines, and you can see here an analysis between the energy generated by leveraging our platform and with legacy systems. Okay, so we have seen an increase in annual energy production up to 20%. And that's it from my side. Thank you very much for your attention. I am pretty much on time, so I hope you can enjoy also the coffee break. Thank you very much.